In this video, we're continuing on with the Infinite Algebra 1 free worksheet scatter plots. Now in number 7, we're going to be finding the slope-intercept form of the equation of the line that best fits this data. So in number 7, they already give us all the points plotted. Now one way to do a line of best fit without a calculator or without a computer is to draw a line that you think resembles the line of best fit. So you're going to take a guess. So I'm going to start here with my line and connect it, trying to get approximately an even amount of points on each side of the line. Now remember, we're finding the slope-intercept form of that line of best fit. So slope-intercept form, if you remember, is y equals mx plus b. So as you can see, my line goes through one of the data points, and that point was 11, 280. So 11, 280 is going to be x1 and y1. Another point, you can see that my line goes through 50, 600. So the next point that I'm going to make is 50, 600. So this is x sub 2 and y sub 2. And we only need 2 points in order to create that line of best fit, because 2 points will help us form a line. So first, let's focus on that slope. Remember, slope is change in y over change in x. So I'm going to have y2 minus y1 over x2 minus x1. That's going to equal 600 minus 280 over 50 minus 11. 600 minus 280 is equal to 320. So we'll have 320 over 50 minus 11, which is 39. So dividing 320 by 39, we get approximately 8.205, which I'll round to 8.21. So that's my slope m. Now we need to find b. And one way to solve for b is by either plugging in x1 and y1 or x2 and y2 in for x and y in our slope-intercept form equation, plugging in m, which we just calculated, and then solving for b. I'm going to plug in x2 and y2. So I'll have 600 for y equal to our slope m, which is 8.21 times x of 50. And then we're going to add that to b. So that's going to be 600 equal to 8.21 times 50, which is 410.5. And we're still adding b to that. So now in order to solve for b, I'll subtract 410.5 from both sides to get that b is equal to 189.5. So for my guessed line of best fit, my equation is y equals m, which is 8.21 times x plus b of 189.5. So that's how you find the line of best fit, by guessing and making an approximation. So in order to find the line of best fit without using a calculator or computer, we're going to take a guess at what we believe that line is, find 2 points that fall on that line, solve for the slope, and then solve for b in order to get our line of best fit and y equals mx plus b form. Now, using a computer, we'll get a more accurate result. And I'm going to use an online line of best fit calculator. So all I did was type line of best fit into Google and click one of the links. Each of them are a little bit differently, but they all complete the same task. So let's start by putting in our points. So 2, 150 is our first point, and currently you can't see it, so let's zoom out a little bit. Our next point will be 11, and then 280, followed by 27 and 490, 27 and 500, and then continuing on with the rest of my points. You can see that I now have my 10 coordinates all within my table. Now in order to see our plots more like in number 7, you can focus in on the data by clicking this button to the left of the one that looks like the coordinate system. which allows you to move our graph. So clicking this, it zooms into the data. Now, unfortunately, it gets rid of our labels, but just refer back to number 7 to see them. Here we can type in what we guessed was our line of best fit. So 8.21 for M, and then 189.5 for Y. And there you can see our guessed line of best fit line. However, in order to see the one that the computer calculates, just click Show Line of Best Fit. So ours is slightly off on the slope and the y-intercept, but respectively not too far off. So what I'll do is I'll write down labeling that this was our guess, and then the calculation or actual line of best fit was that y equals 5.84 times x plus a b-value or y-intercept of 290.73. So our solution in number 7 is y equals 5.84x plus 290.73. And we weren't required to guess in number 7, although I think it's important to understand where the line of best fit is coming from and how it's formed. So by guessing for the line of best fit, we get a general idea of what we're looking for in order to find the actual, which the computer calculated to be 5.84x plus 290.73. And if you were to use a different calculator, you might get a more accurate result. For example, on our answer key, it says that y equals 5.8435x plus 290.73. So for the slope, they went all the way to the 10,000th place. However, for us, it was rounded to the hundredths. Let's continue on to number 8, now that we have a good understanding of the line of best fit. In number 8, we need to construct the scatter plot and then find the line of best fit. Although this time it also asks us to find that r squared value. And the r squared value relates to the correlation, which we will be able to calculate on a computer or calculator. But first, let's plot number 8. So in number 8, we're at 0.1 and then 2,000. Then we're at 0.1 and 2,000 again, so 2 points in the same spot. Next, we're at 2.6 and 3,000, and then 3.7 and 4,000. After that comes 3.8 and 4,000, so slightly to the right of that 3.7x value. And then 5 and 5,000, 6.7 and 6,000, 7.9 and 7,000, 8.5 and 8,000, and then 9.4 and 8,000. So there is our plotted scatter plot in number 8. So let's put each of these into our online calculator. So resetting from the previous problem, I'll add each of my points. Now again, in order to get the scatter plot to resemble what we have in number 8, I'll just click this button, which focuses our view on the data itself. So there we have our scatter plot. And if you want to, you can mess around and try different guesses for the line of best fit. So I'm going to make my intercept at least 2,000, because when we're at 0.1, we're at 2,000 for our first coordinate in our table. And then it seems to be as though we're increasing by at least 1,000 each step to the right. So then I'll make 1,000 my slope. And you can see that looks a little steep, so let's change it now to 900. It's still a little steep, so let's take a more drastic cut. Let's try 600. And that actually doesn't look like a bad line of best fit. So then my guess would be y equals 600x plus 2,000. Let's see how close we are to the real line of best fit. So when we click Show Line of Best Fit, we were only off by 81 for our guess in our slope and by less than 400 in our y, which when looking at the data dealing with thousands is fairly close. So I'll go ahead and write the real line of best fit. And if you want to, feel free to write our guess down as well. So we have y equal to 681.32x plus 1,643.27. That is our line of best fit in number 8. But remember, it also asks for our r-squared value, which this r value they have listed. So our r value for that graph is 0.99, but it doesn't ask for an r value. R is just the correlation coefficient of r. It asks for the r-squared value. So we're going to square 0.99, and when we square that, we get 0.98. So 0.98 is our r-squared value, which we can think of as how closely the data is related to our line of best fit or line of regression. Thinking of that as a percent, we can think of it as about 98%. So our data relates very closely. And our r-squared values are always going to be between 0 and 1, where 1 says that the data relates very closely, whereas 0 means that there's no relation at all. So you can almost think of r-squared as a percent. 0% being no relation and 100% meaning that every single data point falls on the line of best fit. And there's more accurate calculators online, so let's utilize a different calculator. So let's type in each of our x values and each of our y values, keeping them in order, but separating them with the comma. So we have 0.1, 0.1, 2.6, 3.7, and so on. And now we'll type in our y values, keeping them in line respectively. So we'll start with 2,000 and work our way up to 8,000. And then I'll hit calculate. And you can see with this r-squared calculator that we get a more accurate correlation coefficient, which was 0.9916, and when we square that value, r, we get 0.98327, which rounds to 0.983, which is equivalent to our answer key. So again, you may get slightly different answers depending on when and how the values are rounded. So if you just want to double check or get a more accurate answer, look online for a more accurate calculator. But with that last problem, we wrap up the scatter plots worksheet on the KutaSoftware website under the Infinite Algebra 1 section. If you have any questions, please leave them in the comments below, or if you just want to leave me a note, put that in the comments below as well. And as always, like, subscribe, and share.